This is a Mimi HQ video on why spec-driven development still needs a separate architectural governance layer. Hey everyone, and welcome to this explainer. If you're a focused learner trying to cut through all the noise and get straight to the structural realities of AI-assisted software engineering, well, you are in exactly the right place. Today, we're setting the stage for what I honestly believe is the absolutely essential structural evolution happening in AI coding right now. We're literally moving from chaos straight into intent.
That statement right there, that is the core puzzle we're solving today. It's a pretty fascinating paradox in modern AI development, and we're going to break the whole shebang down step by step so you can actually take this and apply it directly to your own workflows.
All right, let's kick things off with the rise of spec-driven development.
Okay, let's really dive into this. To understand this missing layer, we first kind of have to look at the massive industry shift away from that chaotic, unstructured AI coding. You know, what a lot of folks playfully call vibe coding. What we're seeing instead is the rapid rise of spec-driven development, or SDD. In this workflow, a structured specification becomes the absolute, undeniable source of truth for your implementation. Instead of just vaguely prompting an agent to generate code and, crossing your fingers that it doesn't break everything, this workflow promotes the spec from a simple document you just read into an active artifact that the system actually acts on. It's honestly the industry's healthiest, most logical response to unstructured vibe coding.
And listen, this isn't just some niche idea anymore. SDD is totally crossed over into a durable, foundational category, and it's being adopted by the absolute heavy hitters of our industry. Unstructured prompts are out, because frankly, they were giving us all a massive collective headache anyway, and structured specs are in. I mean, look around. AWS is positioning Cairo around it. GitHub actually published its own spec kit methodology, where specs literally generate the implementation rather than just informing it. JetBrains is building workflows for it, and the open source ecosystem. It's exploding with projects like OpenSpec and CC/SDD. The shared consensus is crystal clear here. We absolutely need structure to succeed.
So, what does this actually look like? Let's check out the spec-driven workflow. In practice, the work flows through these incredibly explicit, deliberate stages, rather than just jumping straight from a prompt to code. We start out with requirements, then we move into design, map out an implementation plan, break that down into task decomposition, and only then do we arrive at code generation. Each one of these stages systematically strips away ambiguity. It gives the AI agent a perfectly digestible set of instructions. Breaking tasks down like this is absolutely crucial, because it takes a high-level idea and methodically decomposes it into executable work that an agent can reliably perform. No hallucinations required.
Which brings us to a really vital concept. The specification is the contract for what the system should do. Think of it like a business contract you'd hand over to a construction crew. It tells the builder exactly what needs to be built, say a 3-story office building, right? But here's the crucial difference between a contract and the law. A contract is fantastic for dictating the what, but it absolutely does not dictate the overarching zoning laws of the city.
And that brings us to the architectural blind spot.
Here is the big yes but twist of this explainer. Standard spec-driven development is amazing for generation, for sure, but it has a fatal flaw. You have to ask yourself, which architectural decisions must remain true while the agent builds it? A spec alone simply doesn't answer this. It completely solves generation ambiguity, but it does absolutely zero for architectural governance. Basically, we're handing over the blueprint without enforcing the building codes.
Think about the dangers here. An AI agent can perfectly fulfill the what of a specification, meaning it's 100% spec conformant, and simultaneously completely ruin your architecture. It might introduce a forbidden dependency just because, hey, it was the fastest way to get the feature working. It might bypass your carefully approved abstractions. It could revive deprecated service patterns, or just totally violate your architecture decision records. You know, the documented structural rules of your code base. The agent perfectly followed the contract, sure, but it completely ignored the zoning laws.
Which means we need to talk about specification versus governance.
We really have to treat these as two complementary layers, not competing ones. The specification is purely about what the agent should build. Architectural governance, on the flip side, dictates which decisions and invariants must constrain that implementation. Again, it's the contract for the building versus the zoning laws of the city. You literally need both if you want to build something that actually stands the test of time without collapsing under its own weight.
Notice how beautifully these layers compose across a project's timeline when you stack them properly. It starts with intent, which becomes our specification. But right before we execute, we apply constraint. That is our governance layer. Only then do we allow execution by the agent.
And finally, we end with proof, using verification contracts that prove the result actually held the line. This specific top-to-bottom timeline is exactly how you prevent architectural drift from piling up in an AI-native lifecycle.
So how do we actually fix this? Let's look at Meneme HQ, the structural answer.
So the crucial point is, how do we actually implement that constraint layer? Well, enter NIMI HQ. NIMI HQ is the open-source governance layer designed exactly for this discipline. It provides deterministic, ADR-derived constraints that keep your AI coding agents safely inside your architectural intent while they execute a spec. It is the definitive constraint injected before generation even happens. It's not just some linter that yells at you after the damage is already done.
NIME HQ plugs right into this surface with some vital core concepts. First, we have governance before generation, which means evaluating constraints before the agent writes a single line of code, saving you massive amounts of compute and refactoring time. Next, verification contracts. These are machine-evaluable assertions that actually prove compliance. Then, there's enforcement provenance, which tracks exactly why a constraint was applied so you always have a crystal-clear audit trail. And finally, decision continuity. This ensures your critical architectural decisions actually survive across different sessions, different agents, and different tools executing a spec.
I want to leave you with this really powerful summary statement. Specs improve, generation, governance preserves architecture. Look, if you're adopting spec-driven development to get your AI agents under control, you've already made a massive leap forward. But unless you pair those specs with a robust governance layer, your architecture is going to slowly drift into chaos. You absolutely 100% need both.
So will your next AI agent be a rogue builder, or will it follow the laws of your architecture? The choice is entirely in your governance. MEME HQ, Architectural Governance for AI-Assisted Development. memehq.com